All right, I have this. It's noon, so we'll get going. Hello, everyone, and welcome back for our second installment of the Barn of Tomorrow. Today we have Han talking about livestock sensing technologies. I'm excited to introduce him. He's a relatively new colleague here, still in the ABE department at Iowa State University. He comes to us from the University of Wisconsin-Madison, where he did his doctoral degree, working mostly with dairy cattle and sensing heat stress and other parameters related to them. So excited to hear him share on livestock sensing technologies and excited to have you join us as we start thinking about what the future might hold for livestock production in the Midwest. So with that, Han, thanks for joining us today and the floor is yours.
Thank you. Thank you so much, Dan, for the introduction. Okay, hello everyone. Again, my name is Han. I'm currently an assistant faculty member in this Department of Agriculture and Biosystems Engineering. And let's get this started. Um, then probably maybe slightly mention on the whole Barn of Tomorrow webinar calendar. But however, we're on the second episode of the webinar series. The title of today's talk is Livestock Sensing Technologies. So the phrase livestock sensing technologies can be quite a broad one, and you can say that this could easily be a precision livestock or PLF presentation. However, we wanted to focus more on the actual sensing part of the technology rather than the whole concept of PLF, which can be quite philosophical at times at the moment. So with that, we will start this presentation by defining what we mean by livestock sensing technology, or at least what I mean by it, so we can understand the exact scope of what we're going to cover today. Then we'll do an overview of what the sensing technology landscape is out there currently. And then finally, with the core theme of the Barn of Tomorrow, this webinar series, we'll talk about the current momentum and what it might look like in the near future. So if you want more information about big data in general or an AI related topic, please refer back to last week's episode by Brett. For today, we will not focus on any of the computer vision related technology that can be its own big topic. And if you're interested in that topic, please come back for it on September 23rd, episode by Tony. Also note that this presentation is not about giving any suggestions for implementation or promoting any certain types of sensors. So my goal here today is spread more awareness and interest in these type of topics and share more insight on the future implications. So what are livestock sensing technologies? It's the sensing technologies for data or information that can contribute to the improvement of your livestock operation, simply. Then you might ask what the improvements we are looking for are. The main goal would be improving the efficiency of our available resources, such as labor, feed, and energy. And those improvements can be applied in order to maximize within the existing or given condition, existing facilities, or learn to improve, or the improvement can happen by developing the next generation of practices. And to be able to make those decisions, we need data that can help us do that. And the question could be, where can that data come from in livestock operations? And primarily, those will be from animals themselves and from the barn environment. So why it matters, the sensing technology. So let's talk about the importance for a second. Last week's statement about data, about the big data topic can be, we have an abundance of data and we are still trying to understand how we can better utilize those information. Then this week's statement could be, there are so many different ways to get data, and we are still trying to understand how we gather these crucial information. What's the best way? What tools are out there in order to support the first statement? And arguably, livestock environments are, as you know, probably one of the most dynamic settings for sensing tasks as they are different avenues for sensing locations, such as from animals, biological, climate, and the facility information as well. Okay, so let's start with this. There are, in general, two different types of animal sensing technologies. One is wearable. Sometimes we also include internal body sensors to it. And then there are stationary sensors. Wearable sensors can provide more direct, personalized, or individual data, especially the likes of health, reproduction, or welfare information, for example. Whereas the stationary approach is more geared towards group level or generalized monitoring or at the facility level. The notion is that wearable sensors tend to be more expensive per unit animal unit. This can be partly because you are trying to apply those sensors to each individual animals. But it also owed to components required for portable wearable units to be functioning, and those components being more costly, such as battery sources, as well as use of individual microcontrollers and processor units. So when it comes to individual animal monitoring, we have to think about whether such an approach is appropriate for your production or not. Within their respective production cycle, some animals are in operation much longer than the others, and some have a higher animal unit or value than the others. So as a result, it is common to see dairy cattle with most wearable animal sensors technologies available for them and more accepted within their production. And that will be even clearer as we go through some of the example later in this webinar. Whatever we are measuring with those sensors, how are these data being transmitted? Most of these common wireless or wired types, you probably have seen them all. It's probably not limited to just these six method, but let's go through to organize these information in our heads before we move on to different types of sensors. So Bluetooth and LoRa are common low energy wireless technologies that communicate between each modules, definitely most suitable for wearable sensor communications. Wi-Fi and cellular obviously send information to the internet, which requires more data bandwidth as well as power consumption. Passive RFID is at this point the standard of for animal identification, especially for larger livestocks, and of course, wired, such as USB cables and PoE, are also available. For each of these transmissions, the cost of implementation varies, as well as how much information you can transmit through those avenues. So different applications will require different transmission types. As mentioned in the previous slides, data transmission to the internet can be costly, both in terms of the power consumption and service. So it is common to see the implementation of gateway to support organizing the data incoming from multiple different sources and minimize the required number of communication to the network or to the cloud. Something like Dragino is one of the brand name out of many. LoRaWAN network would be a classic example of a gateway, not only for our sector, livestock operations, but also for any types of other IoT applications. When it comes to sensing, the sensing interval or measurement interval is also very important to consider and think about before we implement these technologies. We often run into two keywords in this concept. One is the concept being the real time. It basically means that from the point it is measured to the point you are able to use or access this data is almost immediate. Another keyword in this field concept is the word continuous. So one might ask, are 1 second, 1 minute, 30 minutes, or an hour all considered to be continuous data monitoring because we see all these different intervals and different sensors all the time. And the answer technically is yes for all of them. It'll be more of a matter of whether the measurement resolution is appropriate or not. For example, measuring dairy core body temperature on the graph on the bottom left, we could measure every 30 seconds or so, or we could still get useful resolution or information for an hour interval, especially when we're trying to link the body temperature fluctuation to the air temperature changes, as though changes are much more gradual. So it wouldn't help us more to measure body temperature for every tenth of a second or every second or so. And it will cost us more energy consumption for that. But if we are monitoring more behavioral or activity monitoring, for example, the walking of a cattle, 30-second will be too coarse of a resolution to be able to interpret the data in any meaningful way. So in that case, we might need more finer continuation of monitoring and logging. So let's do an overview of some of the existing technologies for the livestock. On a higher level, the goal for all species is the same. Being able to monitor their health, behavior, and productivity is the center of all of this. For an individual species, what kind of data we can or able to measure can be vastly different. So let's start with wearables for cattle. For dairy cattle, there is an abundance of wearable sensor technologies available. Pretty much anywhere you see or every parts of the body you see, researchers and engineers have tried wearables or use those locations, from common ear tags and neck collars to ankles and all the way to internal rumen sensors and even the implant sensors under the skin. Cattle are generally the easiest to attach these devices to, as they are larger animals and that the weight of the sensor isn't particularly a concern. A SmartBow branded sensor might be one of the more common sensor for activity tracking and indoor localization in dairy space, dairy operation, where many gateways and wireless transmission, especially low energy Bluetooth transmission, are used to track cows within an accuracy of 1 meter. Four different wearable approaches can be done for beef cattle, pretty similar to dairy in most cases because of the size of their body types and shapes. However, their unique sensors would include, from the dairy sector, would be something like GPS outdoor location tracking, as well as virtual fencing and automated pasture management. As small an animal as they can be, wearable sensors have been applied to poultry in some capacity as well. Probably not realistic to apply a wearable to all individual animals within the building, within the production during the operation cycle. However, this kind of device, especially RFID for location tagging and accelerometers for activity monitoring, would be crucial for poultry production and learn how birds utilize the given facility or interact with the facility, especially as there are a lot of transition coming into cage-free systems, and there is a lot more we could understand about those system and the living conditions. For stationary sensors, a dairy milking robot or milking parlor is a hub to gather many different types of information. While animals are docked, restricted, and their movements and behaviors are predictable, which often be one of the most challenging part of applying these animal wearable sensors. Unique Uniquely for the dairy sector, milk birdies can also tell a lot about the animal's health and information as well. For meat animals specifically, weight gains or feed conversion ratio is the key of knowing the production level. On accessible scale for the animal can provide real-time weight data and then their growth stage. So when it comes to stationary sensors, water and feed consumption would be one of the more important and accessible one that are directly useful. As mentioned before, stationary sensors are very useful and more geared toward for group level monitoring. However, RFID technology can also be utilized and integrated to monitor individual feed and water consumptions per animal level as well. So, what can we do with this data that we're measuring from the animals? We'll not go too deeply into this as there are mountains of example case studies and trials we can go through, and this webinar is more on the hardware side, not the big data. However, this is one case of potential usage via activity tracking of each individual dairy cow. We can map out their activity distribution based on different categories of motions. And then we can easily compare how the production environment conditions, temperature and humidity index, in this case on the graph on the left, affects their behavior distribution, which has a direct link and influence to their welfare and production levels. So far, we can see that data can come from many different sources and in different formats. Rather recently, the term multimodal dataset has been trending. Basically, it means instead of looking at each individual data point separately, combining multiple sources to help get greater insights on those data and help make better decisions. In a sense, the concept is not new because we always looked into different data to determine which source is the most significant or not. However, this has been more of a trending topic as you know, artificial intelligence and machine learning algorithm has been getting better at handling multiple data sets in different formats. So you, for this, you can look at it this way. Sometimes we can get a lot of data from different sources already, and a lot of them um, can be not as useful as we hope them to be. So the question would be whether we can maximize the utility or effectively include all the data we gather in some useful form instead of disregarding or discarding a lot of those seemingly insignificant data points. Up until now, we mostly talk about animal-related sensor technologies that currently exists currently, but we shouldn't forget to mention the environmental and climate sensing in barns, as the growing environment needs to be appropriate for all the animals related and behavioral data to make sense. These are series of data we are capable of measuring and given barns that you might already be familiar with, temperature, humidity, pressure, all the way to carbon dioxide, ammonia, volatile organic compounds. Some are more common and cost effective than the other. A pressure and temperature sensor is definitely important and needed in order to perform proper ventilation control for the given environment. So those are two very common ones. Another, what can we do with this data? For example, now by combining environmental data, humidity and temperature with the feed and water consumption, we can analyze how different environments can influence animals' eating behavior or their dry matter intakes, which is another important metrics we need to look into in animal production. Here, I'm simply including some of the common portable sensors for either evaluating and or troubleshooting the environments of your barn. Might not be as high tech as the ones I've introduced or I've talked about earlier already, but equally or sometimes even more informative, helpful, and convenient than those for many of the cases. So I just wanted to add and state that advanced sensing technology and data infrastructure are not always the answer. And basically, what we are trying to study is if we do implement these new advanced sensing technologies, how do we make the most out of them? So from here, I talked a lot about existing technology that you might already been familiar with and seen before. In the following 10 slides or so, I will try to cover more on the future side of it. Um, Obviously, I'm not here to predict the future and tell you what methods are going to dominate the market or not, but here to share what are some of the new technologies or approaches we see that are trending forward. So with the concept of multimodal data set, we could see a combination of direct animal sensing or animal feedback to the environment affecting the control of the ventilation system. Last week, Brett shared what the current ventilation control space looks like and the integration of big data and AI and machine learning in that space. And multimodal data can provide a platform to combine many different data effectively into ventilation control algorithm. And there are already plenty of studies linking environmental conditions to animal physiological and behavioral changes. So, for example, instead of predicting the best conditions for the animals based on standards and historical data, we could let animals directly tell us whether the environment is healthy and productive for them or not. Um, I didn't really talk about the challenges or limitation of limit wearable sensors in the earlier slides, but one of the main challenge to portable wearable sensing technology is the power source, which also restrict the amount of data you can sample for longevity. It is often that we see some of the crucial sensors measuring the data in the quite coarse way because in order to save energy as much as possible while get the longest data period. For outdoor grazing cattle, a GPS ear tag like this has been implemented a solar panel to lengthen its service throughout available solar power and solar lights, which is not always the case for indoor dairy environments. So for in this example, a rechargeable ear tag can create an opportunity for the sensor to be more complex with higher measurement resolution. A wireless charging station can then be placed somewhere like a milking parlor where animal access and movement are predictable, and then we can predict how long they stay in the milking stall each day. We have already done some pilot study on this, and the bottom graph shows the SOC, the state of charge. That chart that charging every 4 days or so can fully charge the sensor to the max. And in this case, we were doing continuous implant body temperature sensor monitoring through the ear tag. Ultra wideband or UWB technology has been also trending for low power and more precise indoor localization in many other industry. Compared to previous localization tech with Bluetooth with 1 meter of accuracy, UWB can provide finer resolution that potentially can not only provide animals XY coordinates, but also their head position and standing and lying down position as well, all from just single sensor types. This is slight, this is a slight demonstration of how the UWB triangulation is working to pinpoint the exact location of the sensor. And with those information, we could generate heat map, just like the one in the bottom right corner, to view where dairy cattle spend the most time within their residing pen. We can clearly see stalls, water, and feed area is the most populated. They spend longest time in that region. Edge computing is big in the world of IoT. When we think about all the data we gather, where they are stored and processed, conventionally, the data or cloud infrastructure is centralized, so all of the data are stored in one location and processed there. The whole concept of edge computing is to decentralize these processes and have those processes happen locally, close to the location of the source or the sensors. Benefit of this approach would be reduce in latency. Centralized system require data to be sent to a remote server, analyzed, and then returned. It would result in lower bandwidth and connectivity requirements. It would enhance data privacy and security as all this data stays locally, which can be significant as data security in farms and connecting rural regions are sort of a gray area at the moment that we are still trying to figure out what's the best way to implement these wireless communications and potentially cost efficiency. Still a long way to go with this. The edge computers or the hardwares need to be even more affordable and powerful, but it seems like a natural transition to the future of data processing. There are some newish types of detection method through types of wave signals bouncing back from surfaces. This is proposed as a type of contactless sensor and provide a means other than computer vision or camera technology that you're familiar with. You might have seen an article about detecting human body using only the Wi-Fi signals. Wave or millimeter wave is another signal profile for this kind of wave detection. At the moment, a lot of the research and study regarding these approaches resemble the early days of the computer vision object detection method. So there's a great potential for these to create more opportunities with possibly more energy efficient method other than the computer vision that can be used in our operations. Virtual sensing is another concept that arises in terms of livestock, climate, and environment sensing. Um, when implementing these environmental sensors, some of the key questions that everyone asked are, where do I put my sensors? Do I have enough sensors? Or does my sensor network that I've implemented accurately represent the barn environment? With the improvement in technology and approaches, such as different simulation technologies, various simulation methods can be leveraged to advance how we perform crucial sensing methods. Computational fluid dynamics, or CFD, is a rather popular one in the facility design and evaluation tools for agricultural facilities, not limited to just our own livestock operations, but also for grain bin designs and as well as greenhouses. How CFD generally works is you start with modeling based on the physical barn structure, based on those given physical geometry. Computational model is generated, sometimes also known as computational domain or field, given calculation matrix that can represent our model and that the computers and computer CPUs can interpret and process. Then CFD solver will calculate various properties like pressure, velocity, and temperature within the computational field. On the middle figure, you can kind of imagine the finer these grids are, the better chance we have on more accurately recapturing the data or the geometry or the flow pattern around the given geometry. However, this is also the point where we have to balance computational costs versus accuracy in terms of CFD design and modeling. So to give you some example of this approach, here are some in terms of the mechanically ventilated dairy facility. With ventilated air having dynamic and non-uniform flow through the barn, fluid simulation can help identify locations where the critical zones might be. This is an example of the thermal simulation for the naturally and hybrid ventilated facility. Here, the simulation is calculating the distribution of the equivalent temperature index for cattle, also known as ETIC, or it is a type of heat stress index measure other than THI. So with the virtual sensing approach, other metrics like THI can be monitored and interpreted, and not only just direct air temperature and humidity can be measured. Rather recently, I could see more and more studies use simulation tools. Here, I'm showing more of a CFD, computational fluid dynamics results, but also other AI algorithms as well, to determine the optimal position of sensors and potentially minimize the number of sensors required to accurately represent the whole space. I've seen many of those studies happening for indoor plant production structures already. Um, and this is especially important as some of the facilities become much larger and our knowledge gap of how to represent and monitor those environment spaces become larger. Lastly, combining the real data from the sensor and simulation to create a form of real-time simulation feedback can really enable more accurate and reliable virtual sensing. And you probably might have heard the term digital twin. Many of those, any of the simulation outcomes need to be reliable. They need to be verified and validated through the real world data. And this digital twin approach can provide continuous verification of the simulation results to help us um, be more reliable on getting those information from these simulations. I would like to end this presentation by mentioning that eventually, whatever technologies are out there and being developed and tested, they will need to be adopted first. Based on this survey, granted, it's more towards the non-feedlot beef cattle. The cost of implementation will always be the bottleneck, and most of the time, the return on investment can be unclear on implementing these type of sensors. It is a common trend that the new technology normally gets cheaper and more available as it matures and with more time. So I guess what I want to say here is that the collaboration between industry and research and extension institution like us will be crucial to have a better understanding of how new sensing technologies can fit into our existing operations, especially in terms of the cost. As technology continues to advance, not only from within our operation or sector, but everywhere else, and become more available. And as the economic and labor landscape also continues to alter. Thank you so much for the time in the middle of the day on Tuesday. There was a lot of information on the high level. The world of livestock sensing technology is huge, and it will be impossible to cover all of them within the 30 minutes or so segment. But I hope it gave you some perspective and things to think about. If you have lingering question in the future, please feel free to reach out to me via my email, hwchung@iastate.edu. And I can take any questions from you right now.
Perfect. Thank you so much, Han. If you do have questions, feel free to type them in the chat. If I could get you to stop sharing for just a second, Han, I'm going to do our logistics for the next webinar and then ask you a couple questions that came through to me. But if anyone else has other questions, feel free to type them in now. Han did a great job of this for me, and I appreciated so much hearing about the opportunities for sensors that are out there. Next time, we're going to try something a little bit different. We're going to be talking specifically about steer comfort in deep pit and bed pack monoslope barns. And we have Chris Cole, a field engineer here for Iowa State University Extension and Outreach, and Rick Stoll from the University of Nebraska joining us to facilitate that conversation on both design and management of these types of facilities. And then if you have a friend who missed this webinar or you missed last week's, we are archiving the webinars on our YouTube channel. So you can find that at YouTube at Barn of Tomorrow. And if you do like the slides, we have made slide sets available so that you can get them right there at our website from a SciBox. So it all does get posted online if people want this information later. Okay. Okay. One question we have for you to get started is the survey that you showed. Was that done for the beef sector? And is there a full report on that? Do you have a citation or can you tell us any more about that sort of? survey of what people wanted.
Yes. I think Melissa will update the website Barn of Tomorrow, and I put all the citation on the last page at the end. So through that, you'll be able to see the full report on that. And try to find the most recent survey as possible for this one.
Perfect. Okay, in your opinion, do you think the introduction of both more manufacturing and especially the higher production capacity of new microprocessors will play a role in the cost? As you discussed, they might go down for agricultural sensors, and then they gave an acronym SML. I'm thinking of SML and how they're set to start exporting up to 20 of those new high NA machines within the next few years.
I mean, for the cost, production, let me, that's a long question, but especially the higher production capacity in the new markets. I mean, for all of this, livestock industry is almost kind of standalone, and a lot of those technology are developed for general purposes, not geared toward livestock industry at all. Eventually, to bring the cost down, we need more of a more specific manufacturing process for those kind of devices for us and not have more generalized.
Okay, and then I had a couple questions that were sent to me. So one of the questions was, as you think about new barns, what are some of the things we could or should be doing to make them more sensor ready to prepare for upgrades of potential sensors in the future?
So that's the kind of like a difficult question, right? Because we have the building facility design. When we have more of a traditional or conventional building design, obviously we are trying to make them as better as possible. But those design are normally done to expedite the process of animal coming in and out, as well as just environment as possible. And we don't really think about the expansion part of implement when there's a new technology available. These old buildings have a room to have those implementation. So short answer would be as we move forward in the future of these kind of facilities, we should also think about the technology, not only for the workers and animals working in this space, but with the new technology and connectivity also in mind when we first building those facilities as well.
Great. And then I have a question. You showed some heat maps, and as you think about the opportunities to use data like heat maps, it reminded me of basketball and people mapping out sort of the value of shots, and we should only shoot at the rim or three pointers, and destroying some of the beauty of the game of basketball, but really changing the
Nice.
way the game is played, right? What do you see sort of that was an interesting one for dairy cows and where they stand? How is that going to change how we think about barn design or barn utilization?
So if you think about how dairy barns works, that's probably one of the sector where animal move throughout the whole building, right? From milking parlor into the pen area, and then that transition happen daily. So as these kind of facility gets bigger, it might be another logistic questions on how we design those path plan as much as possible. But the general consensus is that we want those animals to be in the pen area resting as much as possible and focus on converting their energy into milk production. So this kind of accurate localization and behavioral distribution can help us um, design or help us have more decision on what design can we do as these facility gets larger and larger. Do we have just one milking parlor and the 4,000 cows supported in that location, or do we separate those locations so we can maximize the time dairy cows are spending in their pen rather than in the transition area? So those kind of um, like a new way of thinking we can do with those type of available data.
Beautiful. And then you got a compliment, great presentation, but asked to comment about thoughts on the role robotics might play in the future of barns and barn design?
I would say that's kind of going back to the implementation part as well. Obviously, for the facility that's much larger, dairy, for example, we have already seen automated milking robots or automated feed pusher or such because we have enough spaces for that, even though when we first designed the dairy barns, we aren't really thinking about traditionally to have those machines. But that's why when we're thinking about the facility design, poultry or swine, we have to have those in mind as well to start building. Um, just building robots to fit into already existing space would be the best solution. Then we don't have to change the facility, but that's not always the easiest path to do so.
Perfect. And as we think about where the barn of tomorrow might take us, we've started thinking about what season two might be. And one of the roles we were looking at, hopefully talking about, was robotics and labor saving opportunities. So if you have one in mind that you would like us to try and get a company to talk about, let us know and we will do our best to facilitate that conversation. So if anyone has a last question, now's the time to type it in. Otherwise, I'm going to give Han the chance for any last or concluding thoughts on his wonderful presentation today. I know I learned a lot about sensing for livestock comfort in barns, and I appreciate you taking the time to talk to us.
Thanks for having me.
And thanks to everyone for joining us. Hopefully, you can tune in again next week for Chris Cole and Rick Stoll talking about some beef finishing housing opportunities and how that may change your production system. Thanks, Han.
Thank you.